Today, we are going to talk about what is free-falling bodies, what are the different principles and law of free-falling bodies, and last, how we can solve problems related to free-falling bodies. What is free-falling? Free fall is the motion of a body when only the force due to gravity is acting on the body. The acceleration on an object in free fall is called the acceleration due to gravity or free fall acceleration. Now we are going to talk about law of free fall. Galileo's law of free fall states that in the absence of the air resistance, all bodies fall with the same acceleration independent of their mass. This law is an approximation as can be shown by using Newtonian mechanics. Objects with the same weight fall from the same height. While objects with different weight fall from the same height. Why do two objects with different masses fall at the same time? Earth gives everything the exact same acceleration. Objects with different masses will still hit the ground at the same time if they are dropped from the same height. Let's see in the case of paper. An object with more surface area will have more air resistance, so the crumpled paper will fall faster because it has less surface area than the flat sheet of paper. Galileo came up with the idea that the objects have the same acceleration. Let's proceed to the problem solving.
In the Earth, the acceleration due to gravity is constant and denoted as g is equal to 9.81 meters per second squared in terms of meters and 32.2 feet per second squared in terms of feet. For the formulas and equations, we will use the equations developed for constant acceleration or direct linear motion. For the velocity at any time, v is equals to Vo plus gt, where v is the final velocity, Vo is the initial velocity, g is the gravitational force, and t is the time. For the coordinate at any time, y is equals to Vot plus 1 half gt squared, where y is the coordinate, Vo is the initial velocity, t is the time, and g is the gravitational force. For the velocity of any coordinate, v squared is equals to Vo squared plus 2gy, where v is the final velocity, Vo is the initial velocity, g is the gravitational force, and y is the coordinate. A ball is dropped from a 50 meters building at rest. Determine its velocity when it reached the ground and the time the ball was on air. Showing here the illustration of the problem, we have the ball dropping from a 50 meters building with an initial velocity of 0 meters per second. State the given. Initial velocity is equals to 0 meters per second. The height of the building is equals to 50 meters and the gravitational force 9.81 meters per second squared. The required of the problem is the velocity of the ball when it reached the ground, which is the final velocity, and the time the ball was on the air. For the equation, we can use v squared is equals to v(o) squared plus 2gy to get the value of the final velocity, and y is equals to vot plus 1/2 gt squared for the value of t. For the solution, v squared is equals to v(o) squared plus 2gy. We can cancel v(o) squared since our initial velocity is 0. Then we can conclude to square root of 2gy. Substitute the value of g and y. Square root of 2 multiplied by 9.81 meters per second squared multiplied by 50 meters. Our final velocity is equals to 31.32 meters per second. And for the second unknown, we have y is equals to vot plus 1/2 gt squared. Since our initial velocity is equals to 0, we can cancel vot. And by formula transformation, we can conclude 2y is equals to gt squared. To get the value of t, divide both sides by g. So t squared is equals to 2y over g. Then t is equals to square root of 2y over g. Substitute the value of y and g. Square root of 2 multiplied by 50 meters all over 9.81 meters per second squared. We have 3.19 seconds. So for the final answer, we have the final velocity is equals to 31.32 meters per second. The time is equals to 3.19 seconds.